Okay, so just reflecting on that last question there, you got to remember we're looking for the equation of a tangent line. And we're going to be looking at a tangent line to many different types of functions. So what we're essentially looking for is we're looking for a point of intersection where that tangent line and the curve, whatever curve it is, where they just meet or touch. So we're essentially looking for, or always going to be looking for, the intersection of a line and a curve at one point. All right. So when you're looking at a question like this, you're going to be using your method of substitution to determine that point of intersection. The second example I have here is that the point of intersection is given. So reading through, determine the equation of a tangent line. Okay, so we want to find the equation of a tangent line. So I'm going to call that g of x equals mx plus b. So m of x plus b. And it's to a parabola, f of x, and that's 2x plus 1 squared minus 3. And the difference is we now know the point of intersection. We know the point of intersection here. So I'm going to give myself a sketch. I always recommend giving yourself a sketch here because it helps you visualize what's going on. So we know that the parabola, the vertex, is located at -1, -3, and I know it opens up and is skinny. So 1, 1, 2, 3. I don't know if I drew it skinny enough. And we know our point of intersection is at 1, 5. Okay, well, I'll cheat a little bit here. So there's the point of intersection. If that's the point of intersection, that tells me that I have a tangent line that meets right there. So there is my g of x, the green line, and this is my f of x, the parabola, the blue line. So there we go. So I know the point of intersection. So if I know the point of intersection, I'll just put that down here. No point of intersection. What do we do now? Oops. So the answer is we got to find m and b. Okay? We need to find the slope and the y-intercept for our line. Well, I can't find the y-intercept until I know the slope because I don't know how steep this line is going to be. So we got to find slope first. All right. So determine slope of tangent. And how am I going to do that? Well, how many equations do you know for slope? At this point in time, we've got to go back to what we know from grade 9. But we do need a little bit from grade 12. Okay? Because if I asked yourself, how would you find the slope of a tangent line right now? This is what you'd tell me. From MHF for you, you would take the point, 1, 5, and then you'd find a second point, 1.0001, and whatever that was, and then you'd use slope. Okay? So that's what you would do from before. And that's exactly what, it's a fine process. But now in the calculus, I want exact value. I don't want an approximation. So I don't want to go through this process of the 0.0001 all the time or whatever, how many zeros you're using. So instead, I'm just going to leave that b value, the x value in b, I'm just going to leave it as an x. I know the answer is 1. And I know it's going to give me a problem in the denominator, but I'm going to see if things will shake out for me first. So going back to this, I know that the y2 is going to be a 5. I know the x2 is going to be a 1. And instead of having a numeric value, I know that the y1 and x1 is going to come from the parabola because you would substitute the 0.01. I know you would substitute the 0.01 into the parabola equation to get the y value. So instead of doing that, let's just leave it as x. So I'm just going to substitute that entire parabola equation. And on the bottom, I'm going to just leave it as x. So I'm looking for an exact value. I know x is equal to 1, but that gives me a problem, doesn't it? Okay? 1 minus 1 is 0. What I'm going to do is I'm going to kind of curl up in the fetal position, and I'm going to pretend the problem doesn't exist for a minute. I'm going to say, no, we have no problem, and I'm just going to continue along. And I'm going to show you what happens when you deal with the question this way. So we got to be careful here. Got to do our distribution first. So I'm going to distribute that negative 2 in, and that's going to become a positive 3 over 1 minus x. Now I need to expand the x plus 1 squared. So I get x squared plus 2x plus 1 plus 3. That's all over the 1 minus x. And then distribute that negative 2 in. So I'm doing this in a ton of steps here, so it's easier to follow. That's over 1 minus x, and we'll just scroll down here. Okay, so collecting like terms on top. So I'm going to end up with negative 2x squared minus 4x. 5 take away 2 is 3, plus 3 is 6, so plus 6 over 1 minus x. And remember, we still have a problem here, okay? So we're all curled up saying, no, 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 we don't have a problem. We're pretending at this point there's no problem. What are we going to do in the numerator? We take out the negative 2, and we're left with x squared plus 2x minus 3 over 1 minus x. That's a simple trinomial, and it factors. So x squared plus 2x minus 3, so we needed to add to 2, so it would be x plus 3 and x minus 1. Now, it almost looks the same as the bottom. And if I change it up, made the bottom x minus 1, it would be exactly the same. And we do that by factoring out a negative out of the 1 minus x. So it makes the x positive and the 1 negative. And now, the x minus 1s will cancel out. My negatives cancel out. So guess what? The problem disappeared for us. So this time ignorance was bliss, and it worked out. Now, what do we have down here? The whole way down, this is slope. So what do I actually have? This is an expression for the value of the slope of the slope of a tangent at any point. So I have an expression here, I have an equation. I not only know the slope at point A, I know the slope of my tangent line for every tangent on this parabola. I just have to substitute in the x value to find that slope. So I'm going to move over here. Now we're only interested for point A. So slope will equal 2 and then the 1 plus 3. But I could find the slope at any point on the parabola technically here. So my slope is 8. So therefore, my equation of a tangent is equal to 8x plus b. But I know it passes through 0.15. So using point A, which is 1, 5, 5 would equal 8x, which is 1, plus b, and we'd end up with negative 3 equals b. So therefore, the tangent line is 8x minus 3. There's your final answer. So it avoided, what I've essentially done is I've avoided using this process that you used all last unit. Every time you had to find instantaneous rate of change, you're using 0.0001. What I'm telling you to do now is do the exact same process, except don't use the 0.001, substitute in the entire equation, curl up in the fetal position, and ignore it, and hopefully it fixes itself. Okay? And we're going to talk about, well, what happens if it doesn't. At this point, it will fix itself. What happens if it doesn't, and we'll deal with that in a little later lesson. So there you go. So there's the assigned homework. If you have any questions, you know exactly how this works. Make sure you write down what your questions are, though.